Hello everyone, I welcome you all for today's learning. Today we will be seeing an important topic or the important concept which we will be observing all around us. So see here there is a picture of an apple falling from a stem. Okay, so look at this picture. In this picture, an apple is hanging from a tree and we have a stem to the tree, and when this stem breaks down from the tree, what happens? Have you ever noticed that? So the apple which was to the stem falls down to the ground. Okay, so this is your ground, that is the earth. So whenever the stem break down, the apple or any object on the stem falls down to the ground, and the apple does not stay in the air. So whenever the stem breaks down, it falls downward, but it does not stay in the air. This is your air. This does not stay in the air, or this apple does not fly in four direction. Like whenever it falls, it don't move in this direction, or it does not move in this sideway direction. It falls right. It falls straight down to the earth. Why? Have you ever observed that? Because the earth is pulling this apple. This is your earth, and this earth, it is pulling your apple with a force called gravity. Okay, the earth, whenever an apple fall down, it falls to the ground with a force called gravity. Yes, they actually do, and Newton discovered that every object in the universe attract other object. This earth be your one object, and this apple be your other object. So in universe, every object is attracted by other object. So here earth or apple, they are attracted by each other. So the pull is happened with the force called gravity. Okay, and right now you might be listening to my class, and might be you have a pen and notebook along with you, and if in the case if you are note downing what I'm saying, you are writing with the pen on your notebook. Okay, here your pen is pulling your notebook. Because of the force gravitation, your pen is pulling towards your notebook, and you are able to write on this notebook the points I'm telling. And you might be listening to the class by looking at my video, by sitting on a chair, and your body is pulling on the chair so that you can be stably sit on a chair and listen to the class, right? But these forces are very tiny that we do not notice. Okay, the really noticeable is only the one which is earth pull, right? We only notice that we have earth pull, which we call as gravity, but all other objects around us, like I mentioned, a notebook or a pen or a chair and your body, all these are forces by gravity. Okay, all these simple observations like this apple falling is what made Newton think something. He thought that if the earth can pull this apple, maybe it pulls the other object too, right? And have you ever wondered that why does an apple always fall down and not sideways, right? Apple always fall in this direction, right? It falls down to the straight direction to the earth, but it does not fall sideways. And have you ever wondered that why the moon never crashes into the air but also does not fly away into space? Okay, we have seen all these real life examples, and daily we all look at this around us. Okay, all these observations made Newton think something. He thought that maybe every object in the universe pulls every other object. Okay, this may be your first object and this is your second object. He thought that every one object is pulled by every other object, okay, with the force called gravity, right? And that's how he came up with the concept called universal law of gravitation. So in this image, basically we have shown that there is a force of attraction between earth and apple. Due to this force of attraction, the apple fall down on the earth, right? Due to this force of attraction, it fall down straight away to the earth direction, but not to the sideways or upwards direction. And the arrow point which is downward here is the direction of earth gravitational pull, and the apple falls because earth gravity act on this, right? Apple fall down to the earth direction because the gravity of earth act on this apple. Well, all of this can be explained by Newton's a concept called universal law of gravitation. Let us break it down in the simplest way. So here is the law. First, we'll try to understand this by a simple definition. We'll look at the definition. Here, the universal law of gravitation says that every object in the universe pulls every other object with a force. As we have seen in this image, the earth is one object here and apple is one object here. So these objects in the universe are pulled by each other. Okay, it states that universal law of gravitation says that every object in the universe pulls every other object with some force, and this force depends on their masses, like how heavy they are. Masses, we can say it as weight, and the distance between them. So this is a simple definition of universal law of gravitation. So the force of gravity depend on two things, right? The force of gravity depends on two things. What is your first one? It is masses of the objects, and the second is distance between that objects. If suppose you have more mass of an object, right? If there is more mass an object, there will be stronger pull. And if you have more distance, there will be weaker pull. Okay. As we have seen in the previous image, an apple and the earth. Here, the mass of the earth is very huge. Okay. The mass of the earth is very huge. Due to this huge mass, there is stronger pull towards the apple. Okay. Because of this pull, it falls straight down to the earth. And Newton even gave us a formula. Okay. He also gave us a formula to calculate Newton's law of gravitation. It can be calculated by F equals to G into M1 into M2 by R square. Here, your F is gravitational force. F is your gravitational force. M1 and M2 are your masses. R is your distance, and G is your universal constant, right? So we have a simple formula to calculate universal law of gravitation. Now don't worry, you need to calculate this every day, but the simple formula explains the whole universe around us, as we have seen the example of apple falling down to the earth. Okay. Next, we will see another example. Here, see, we have all the planets. We know that all the planets rotate around the sun. So as you can see here there is a sun and here we have few planets. Now we can see that the mass of sun is very huge. Sun is huge. So sun is very huge. Because of its huge mass, the gravitational pull is very strong. Okay. As the weight or the mass of sun is very huge, the gravitational pull of the sun is very strong. And that's why all the planets, including Earth, are pulled towards the sun and keep moving around it. Okay? Because of the huge mass of the sun, all the planets, including Earth, keep moving around it due to its strong gravitational pull. Right? Due to its strong gravitational pull, they all move around it. So, bigger mass equals to strong pull. And as you can see here in this diagram, the first planet, let's say it is Mercury, it is very close to the sun. So now the distance between the sun and Mercury is not that much, right? The distance is very little. So whenever we have less distance, we have very strong gravitational pull. Okay. Mercury is very close to the sun, so it feels the strongest pull, so it moves fastest around the sun. The very first planet to the sun moves fastest around the sun because of the very little distance between the sun and Mercury and the very strong gravitational force of the sun. Similarly, the last planet, that is Neptune. Here Neptune is the last planet which is far away from the sun. As you can see that we have a very large distance from your sun to the Neptune. So if the distance is more, there will be weaker pull. Okay. If the distance is more, there will be weaker pull and it moves very slowly around the sun. Right? The sun is here, the sun's mass is very big, so it pulls all the planets with its very strong gravitational force, and the nearer planet is the stronger to pull because of the less distance. Right? Everything in the universe is pulling on everything else. So that's the concept we apply, what we call as universal law of gravitation. A simple idea that explains apples, moons, planets, and even galaxies and even other objects. Right? If you learned something new today, don't forget to like, share, and subscribe for more simple lessons. Hope you enjoyed it and understood it very clearly. Thanks for watching. Subscribe for more upcoming videos so that you can get notified what I upload. Thank you.